So today we start a new unit. Okay, our new unit is called Systems of Equations. I figured you could figure that out because I wrote systems of equations on the piece of paper. All right. So let's use our context clues and see if we can remember what this means. What do we know about systems of equations? What does this tell you? There's more than one, right? More than one equation. Okay. So a system of equations is more than one equation with the same answer for every equation in the system. Okay? So it's important to know this, though. If this is one of my equations, I recognize how many variables there are in this equation. 2, right? 2 variables in this equation. The rules of systems of equations is if I have 2 variables, guess how many equations I need to solve it? 2, right? I need at least 2. I can have more than 2. It just gives me extra information. But if I have 2 variables, I need at least 2. Looking forward to Monday, give you a little foreshadowing, we're going to be talking about systems with 3 variables. Guess how many equations we're going to need? 3. Yes, 3. Okay? So I'm going to tell you this. Here's the system of equations we're going to work with today. Okay? Now, what does this little bracket thing mean right here? It means this is a system. It's not always going to be there. Okay? Especially if the problem says solve the system of equations, you can pretty much know that the 2 equations or 3 equations they give you is the system. Okay? But sometimes you're going to see this brace right here, and I just wanted you to be aware of what that meant. Fair enough? Okay? There are 3 ways that you need to know how to solve a system of equations. Okay? The first way is graphing. Guess how you solve it? Yeah, by graphing. That's exactly how. Okay? To solve a system of equations by graphing, we have to graph each equation. In order to graph these equations, what do I have to do to them first? Exactly. I've got to get y by itself. Okay? So if I have the first equation, if I'm talking specifically about the first equation, how do I go about getting y by itself? If I subtract x here and subtract x here, I get y equals negative x plus 7. Now, earlier when I said, what does that give us? Somebody said 7 minus x. And people were like, that's wrong. That is not right. Well, why not? It is, isn't it? Now, is it in slope-intercept form? No. But can we graph a line even if it's not in slope-intercept form? Yes. Okay. So, does it matter what order we add in? It does not. Okay. So if you wrote 7 minus x right here, that is so great. All right. I wrote it like this because I'm kind of used to graphing from slope-intercept form. Fair enough? God bless you. Okay? Now, what if I wanted to get this bottom one into the form I want it y equal? Same thing, right? Subtract x from both sides? Because the x is positive, so I have to subtract it, right? So that gives me negative y equals negative x plus 1. Is that solved for y? It's not, is it? What do I have to do to solve it for y? Divide everything by negative 1. Okay? When I do that, that gives me y equals x minus 1. Got it? Now we have to graph it. Well, see how amazing I can be with my graphing this period. You should have seen it earlier. It was so awesome. I say that with a little sarcasm, just so you know. 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 1, 2, 3, 4. So how did I graph this first line? What is my y-intercept? 7. That means I go on the y-axis 7. 1, 2, 3, 4, 5, 6, 7. And what's my slope? My slope is -1. My slope has to be a fraction, though, over 1, right? So from this point, from my y-intercept, I'm going to go down 1, which takes care of the -1, and right 1. And I put a new dot. From that dot, I'm going to go down 1, right 1, down 1, right 1, down 1, right 1, and so on, until I run out of room. And then we're going to pretend that that's straight. Right? So how do I graph this other line? Same kind of questions, right? What's the y-intercept? -1, so I go down 1 on the y-axis, and I start there. What's my slope? My slope is never x. My slope is always the number in front of x, right? The coefficient of x, and I need it to be a fraction, so I have 1 over 1. So from here, I'm going to rise 1 and run 1. Rise 1 and run 1. Rise and run. Rise and run. Yikes, that was bad. Hold on. Oh, it's right there. Sorry. Rise and run. So we have to really pretend this time. It's supposed to intersect right there. Why do we care where it crosses? Because that is the solution, right? That's the solution. Where 2 lines cross is the solution. Is it possible for 2 lines not to cross? If they are parallel, exactly right. Okay. Is it possible to have more than one solution?
Yes.
2 lines can cross in 2 different places?
Not lines.
Not lines, right? And that's all we're talking about so far is linear functions, right? So is it possible to have more than one answer?
No.
That was a trick question, just so you know, because the answer is yes. What if the lines were right on top of each other? How many answers is there? An infinite number, right? Okay. So, but think about it. We can have one solution where they cross one time. We can have no solutions, or we can have all of the solutions. Okay? This would be one solution, this would be no solutions, and this would be all of the solutions, or infinitely many solutions, right? But what we care about right now is what? Where they cross. Okay? You guys probably did a better job at graphing this than I did. Where does yours cross? 4, 3. Is that where yours crosses? Good. I mean, is that right? Is there any way for us to know if that's right for sure, for sure? Oh, so we could plug it in? Is that what you're saying? All right, x is 4 and y is 3. 4 plus 3 equals 7. Oh, yeah, it does. All right, 4 minus 3 equals 1. Yes! What does that mean? It's the right answer. Okay? Because I know that the answer is what? The point of intersection. Yes? I don't know what this thing is doing. It's like being weird, so I'm sorry. Okay? So the first way you need to know is by solving by graphing. Okay? The second way you need to know how to solve a system of equations is substitution. So what does that word mean to you? When I say substitution, what do you think of? Okay? So I said that to a class earlier. I said, when I say substitution, what do you think of? And like 3 or 4 people at the same time were like, Mr. Weems! Right? Isn't he a substitute here? Right? He's a good substitute too, isn't he? He's polite to you and he does what we ask, doesn't he? Okay? You never have to worry if he's doing the right thing, do you? Okay? So that's a good type of substitution, right? If I have to be gone, I like for Mr. Weems to come and be my substitute because he's going to do what I would have done. For the most part. You know what I mean, right? Okay? Now, he's probably going to press play because I'm probably going to leave a video for you of me teaching, right? But that's what I would have done, right? I would have taught you, okay? So the same kind of thing is going to happen here. Now, in case you're confused, what do you notice about this system of equations that we're doing? It's exactly the same as the one we just did, isn't it? Okay? Why am I doing exactly the same equation? Well, first of all, we already know what the answer is. So the answer is not the important here, it's the process. Fair enough? Okay. Second of all, I just like this system. It's a nice one. Okay? So when we solve by substitution, we have to isolate a variable. Doesn't matter which one we choose.
No.
Not really. I don't want to just flat out say no. I want to say not really. Okay? Some of these variables might be easier than others. Okay? If I was choosing between, well, let me ask it this way. Which variable do you think I would not choose?
The negative one?
The bottom? Which one?
The bottom line.
Why would I not choose the bottom y?
It's already negative.
Because it's negative. I don't want to have to deal with that. If I have a choice between a negative and a positive, I'm going to choose the positive because then I don't have to divide everything by a negative and have an opportunity to mess up a bunch when I have to switch signs, right? So of these three, do you think there was one I would prefer over the others? There's not, right? They're all variables that are by themselves. They don't have any other coefficient besides 1, okay? What if this was a 2 and a 4 and a 6? What do you think I would choose? The 2, right? Sometimes. If this was a 2 and this was a 5 and this was a 7, wouldn't I have to divide everything by 2? And this would give me fractions, wouldn't it? So it's just something that we have to think about when we go to decide which variable to choose. Okay? It might be better to choose this one down here that might be a 3, right? One of these that's a 3, because then I got a 3 and a 6, and we can pretend this is 18. Because that would be nice, wouldn't it? Everything would divide evenly, wouldn't it? Okay? So that's just something to think about. All right? There's some like that on your homework, so just give yourself time on that. All right? So which one do you want to solve for then? Which one of these three do you want to solve for?
X minus y equals 1.
Okay, so what I'm asking you is choose one of these variables. Not choose an equation, but choose a variable.
X.
Which x?
The bottom one.
Top one? If I'm choosing the top x, I'm going to isolate the top x. How do I isolate the top x? Subtract y from both sides, don't I? If I subtract y here and subtract y here, x equals 7 minus y. Ooh, they didn't like that when I did that earlier. Why not? What would they want me to write? Negative y plus 7. They were like, the variables always have to come first. So what's going to happen? Are the variable police going to come in here?
Yes.
No. No, they are not. Okay? We're not asking for a specific form right here. As long as it's correct, we can put whichever one first that we want. Okay? So here's the deal. I got this value of x from one of the equations. Once I do that, I go to the other equation. And I'm going to start rewriting this equation. But this time, instead of writing this x, I'm going to write what I know x equals, which in this case is 7 minus y. So I'm going to write 7 minus y, because that's what x equals, minus y, because that's here, equals, because that's here, and 1, because that's here. Now, what do you think my goal is now? I got to combine my like terms first, okay, so let me do that. 7 minus 2y equals 1. Now what's my goal? Isolate y. I'm trying to solve for y, aren't I? Okay? So how am I going to do that? Subtract 7 from both sides. Negative 2y equals -6. I'm running out of space, sorry. Divide both sides by -2. Y equals what? 3. So now I'm done, right? I'm done with this problem. Woohoo! Wait, I'm not? Why not? I got y. Y equals 3. Oh, I don't have x. Dang it. Is x really that important? Do we really care about x? Yes. Yes, we do. Okay? So how do you think I should go about solving for x? What you got? Like over here somewhere? Oh, right here? Oh my gosh, that would make so much sense because x is already solved for. I should take this and plug it right in there, don't I? X equals 7 minus 3. X equals 4. So here's a good question. I know it's a good question because I am asking it. How do you write the answer? Why would I want to write it as an ordered pair? Yeah. Didn't I just prove up here that I know that the answer is the intersection of the lines? So even though I'm not solving this by graphing, my answer is still where the lines intersect, isn't it? So I still want to write my answer as 4, 3. Most of the time. I know, I hate that face you give me when I say stuff like that. Most of the time, right? Well, let me show you exactly when it's not going to be written like this. Okay? What if this problem I gave you from the very beginning said this? Do we graph on the M and R axis? No. So we usually reserve writing our answers as ordered pairs when it's something that we could graph on an X and Y axis. Okay? So when we're given something like this, it's very possible for you to write your answer like this, but you have to give me some more help. You have to tell me this is M and this is R. Or you can say M is 4, R is 3. Okay? I don't know which one of these is which. M and R, I don't know which coordinate it is, so you got to help me. Or just write it like this. Does that make sense? So how many ways did I tell you we had to know? 3. So I've shown you 2. You ready for the last one? Okay. Elimination. Elimination really truly has nothing to do with assassination. That one's illegal. Okay? Elimination of systems of equations is perfectly legal. Okay? We're trying to eliminate variables, not people. Fair enough? Guess which equation we're going to use? Our favorite ones! So, the way we do elimination is we do all sort of changes and manipulations to the numbers, the variables, things like that. And then at the very end, we combine the two equations together. And we hope that by that point, when I combine the two equations together, one of the variables will go away. It will be eliminated. In case you were wondering why it was called elimination. Okay? So, does anybody notice anything about it right now? If I combined them right now, the y's would go to 0, wouldn't they? Okay? That's too easy for the lesson. Okay? That happens on your homework. You combine them exactly as they are right now, and you go to town and find the other variable. Okay? I want to make sure you understand that the math that's going on behind, just in case it doesn't show up like this easy on your homework. So let's pretend we want to eliminate the x's instead. Okay? What do they have to be for us to be able to combine them and eliminate them? They have to be opposites, right? Same coefficient, same number, but opposite of each other. like the y's, I have a positive 1 and a negative 1. That's why we're able to combine them as they were, and we get 2x equals 8, and guess what x would equal? 4, right? We already know the answer. We've done it twice already, okay? But, again, I want to eliminate the x's. Are they the same coefficient right now? Yes, but they're not opposites. So what do we do to make them opposites? I can't subtract, not at this point. I can multiply by negative or divide by negative. Okay? So which equation do you want to multiply by negative? Okay, so that's a good question. Does it matter? At this point, it does not. Okay? Because we already got a 1 on both of them. So let's multiply the whole bottom equation by negative 1. I'm going to trick you. Well, I'm going to try to trick you. X plus y equals 7. Negative x plus y equals 1. Why would it be negative 1? So the whole reason I did this, remember I told you I was going to try to trick you. I didn't trick her. She saw it. I think several of the others saw it. If you're going to mess up, it'll be right here. You'll remember to multiply this by negative 1. You'll remember to multiply this by negative 1. And this is the one you'll forget. Don't forget it. It's the whole equation by that negative 1 in this case. Okay? Good job. Now, let's combine the two equations. What do I mean by combine? Well, sometimes people say add, but that can get confusing sometimes. We're just going to put them together, right? What is an x and a negative x? 0. What is a y and a y? 2y. What is a 7 and a negative 1? 6. How do I solve for y? Divide by 2 on both sides, so y equals 3. If y equals 3, how do I find x? Plug it in where? Okay, I get that I plug it into y, but where? So like one of the first original equations? It's probably the best idea. Okay? So x plus 3 equals 7. Minus 3 on both sides. Very good. X equals 4. What's the answer? 4, 3. That's elimination. Now, that one was pretty easy, so let me kind of throw some stuff at you to talk about real fast. Okay? What if the problem looked like this? 2x minus 3y equals 11, and 3x plus 4y equals 75,000. Now, we don't care about that, though, do we? So it doesn't matter if it's 75,000. Which variable would you try to eliminate? Well, if this was a 6, let's think about this being a 6 real quick. I'd have a 6 and a negative 3. That'd be pretty easy, right? I'd multiply everything in the top by 2, right? To get a negative 6 and a positive 6. But I don't have that. So I have a couple things I could do here. I could either go ahead and try to eliminate the y's because they're already opposite. If I'm going to eliminate the y's, what do I have to multiply the top one by? A 4. And what do I have to multiply the bottom one by? A 3. Just to get the same number, 12, right? A negative 12 and a positive 12. I could just multiply this one by 4 and this one by 3. Well, the whole equation, right? Not just that one term, but the whole equation. But they would be opposites then, wouldn't they? Could I choose to eliminate the x instead? What would I have to multiply if I eliminated the x?
The top one by 3 and the bottom by 2.
That would be really close, because that would give me 6x and 6x, remembering they have to be opposites, right? Could I do negative 2 or could I do negative 3? It doesn't matter, right? As long as one of them's positive and one of them's negative in the end, right? Any questions? We good? Okay, now this is all just a reminder from Algebra 1. But I know it's been at least 2 years since you've seen this. That's why I wanted to spend today just going over some 2 variable systems. You okay with that? Are there any questions?